Hello everyone, welcome back to my YouTube channel. This is Mr. H. In this video, you will be learning how to solve systems of linear equations using elimination method. But first, let's take a look at some important notes about system of linear equation, which is a set of two or more linear equations that have the same variables. And we're solving the system and looking for the solution to the given system. And the solution is an ordered pair, or a point of intersection of the given lines in the given system. So there are three different cases. The first case is when the two lines actually intersect at one point. We're definitely looking at one solution right there, because as per definition of solution, it's the point of intersection. So for the first case we're looking at right now, this is the solution to the given system. The case number two, where two lines are actually parallel to each other, and we're looking at no solution for this because two lines do not intersect. And the third case is actually if two lines are coinciding. So if two lines are coinciding, if that's the case, definitely you're looking at infinitely many solutions, because all the points that lie on the line are considered solutions to the given system. To better understand about elimination method, let's answer an example. Solve the given system. At first, you notice that each equation needs to be rearranged. So the first equation is actually written in standard form, and the second equation is written in general form. So before you start solving, make sure that each equation is written in the same form, and make sure the x terms, the y terms, and the constant terms are actually aligned. So let's take a look at rearranging first. So if for equation 1, I would say that I'm going to be putting negative 6x to the left. So from negative, it will become positive. So I will have positive 6x, and then I copy 14y. So positive 14y. However, the constant term, which is negative 6, needs to go to the right-hand side. So by applying the addition property of equality, we add 6 to both sides. It will become positive 6. And for the second equation, which is in general form and needs to be rewritten in standard form, which is pretty short because here we just move the positive 11 all the way to the right-hand side. That will make it negative. So I copy negative 4x. I copy negative 7y equals to negative 11. So once the equations are already organized, then we're ready to start applying the elimination method. Now for elimination method, the first thing that you need to think about is which variable do you plan to eliminate? So in this case, I would like to eliminate variable y. So in order for me to do that, I noticed that on the first equation, the y term has a coefficient of positive 14. Now, in order for the y variable to be eliminated, the second equation must have negative 14, because positive 14 plus negative 14, you'll get 0, and the y variable will then be eliminated. So in order for me to do that, I need to multiply the second equation by positive 2. So both left and right. So for equation 1, I don't do anything, so I just rewrite it. And for the second equation, I need to multiply each term by positive 2. So 2 times negative 4x is negative 8x. 2 times negative 7y is negative 14y. 2 times negative 11 is negative 22. And proceed to adding them. So from here you can see 6x plus negative 8x results to negative 2x. And positive 14y plus negative 14y is actually eliminated. So that's the goal. And for the constant terms, we have 6 plus negative 22 is negative 16. And from here, you can actually see that we can find the value of x by dividing both sides by negative 2. Cancel, and you have x equals to negative 16 divided by negative 2 is positive 8. Now we already have the value for x. And for the next step, we need to find the value of y, which will complete our solution, or the point of intersection of these two lines. So in order to find y, we will use the value of x that we got by replacing it to any of the two original given equations. You can use equation 1 to find y, or you can use substitute x equals to 8 to equation 2 to find a y. So either of the two equations will do. Okay, so let's use the first one. So I'm going to be using the first equation, 14y minus 6 equals to negative 6x. So from here, I will substitute the value of x, which is 8, to the equation. So I will have 14y minus 6 is equal to negative 6 times positive 8. And then keep simplifying. So we have 14y minus 6 equals to negative 48. So we'll have negative 14y equals to negative 48. Then negative 6 will jump over to the right-hand side, so that will become positive. So from negative, it will become positive. So 14y is equal to negative 48 plus 6 is negative 42. So to find y, we divide both sides by 14, and you have y equals to negative 3. Now we already got our values. So from here, we can say that the solution to the given system is at 8, negative 3. So how are we going to interpret the solution here? So the solution, based on the definition of it, is that it is a point where the two lines will meet. So you have two ways to check. So first one is graphing. So if you graph the first equation and the second equation, the graph must show you that they will meet at this point, 8, negative 3, which is in quadrant 4. Yeah? And the second method, in order for you to know if the solution that we got is correct, is by simply substituting the value of x, which is 8, and the value of y, which is -3, to both equations. And it should give you true for each given equation. If that happens, definitely the answers that we got are correct. And for your challenge, please grab your pen and paper and answer this question. Solve the given system of equations. If you learned something new from this video, please remember to share your answer by writing a comment below. And please remember to subscribe to my YouTube channel and like this video. Thank you very much for watching.